I'm Anil Kumar. Welcome to my YouTube channel, the website, and the WhatsApp group. WhatsApp group is very active these days. We are getting many questions. You can always join it. So in a couple of days, we got about 6 questions related to this topic, which is finding area where sectors are involved. So I've taken up this question from one of our subscribers who wants to really understand this topic, and that's the kind of question which we are going to discuss now. I hope its solution will help many others. Now, since there have been a couple of similar questions, I am trying to summarize the approach. One of the important things which I understand is that while doing calculations, you will definitely need a calculator. You need to set this to radians, right? So you have different ways of doing it on different calculators. In my calculator, you have to do shift mode and then select 4 to get to the radian mode. So that's the very first thing to be very careful about. Now, we are taking these two examples here. There are two circles with centers slightly apart. So one of the circle is protruding outside. We need to find that area. And in this particular case, we have combination of circle with a rectangle. And we need to find the shaded area. Formulas which you will normally need to work with are also given on this page. So it can be taken as a reference page for this topic. So as you know, these formulas, area of triangle, half base into height. And in trigonometry, we use any triangle ABC. In that case, area is half AB sine C. And if both A and B are equal to R, the radius, as is the case when we are working with circles, then it is half R squared sine theta, where theta is the angle subtended at the center. Circle pi r square, area of the sector is half R squared theta. You can always see the similarities between the triangle and sector area. Half R squared theta is the sector area, but when you write sine theta, it becomes triangle area, right? Sometimes we'll be working with segment areas, which is difference of these two. For example, in this particular case, that's the segment for you. Right? So if you need to find the segment area, in that case, find the sector area, take away the area of the triangle, and you get this segment area, which is sector area minus triangle area, half R squared theta minus, this is the sector area, which is always bigger, and the triangle inside, half R squared sine theta, correct? So that is how you could do most of the questions. Now, related with this is also to find the perimeter of the shaded region. So we'll extend, you can always extend the question to find perimeter. So once you calculate all the side lengths, you to just add them up to find the perimeter, which will not be a part of this video. Anyway, those are the variety of questions which you have on this topic. We'll also not calculate the segment area. That will be part of another video. But you could always use the formula mentioned here and extend these questions to cover up those things also, right? So let's begin with the very first question, which is, in the figure below, OC is perpendicular to the chord AB. So this is perpendicular to the chord AB of length 16 centimeters. This total length here is 16. AB is also diameter of smaller intersecting circle C. So that is the center of smaller circle. Find the area of circle which is not overlapping if the radius of the bigger circle is 10. So we are given this as 10. This radius is 10 here. Half of 16 is 8. Let me write 8 here. We need to find the area which is not overlapping, which is this area, right? So I hope the question is clear. You can use the formula sheet and then answer this particular question. Let's try to see the strategy to solve this. Okay. Now, in order to find that particular area, what should I do? I can find, of course, the half circle area, the smaller circle, right? So we need half of smaller circle areas. So that is one thing which we can directly find, pi r square and half of it. So let's do that. So we have half of pi r, in this case is 8. So let's calculate this value. So 8 squared is 64, we'll just divide by 2 and then we'll times it with pi, which is 100.531. So let's write this as 100.531. So that is one area. So that means we have this area. Clear? Now we don't want that segment area, right? So that means we have to use all the formulas which are mentioned on the very first sheet. To find the segment area, we should find the sector area of the bigger circle and take away the triangle area, correct? So all the formulas will be used here. So sector area for this circle. Now we don't know the angle, so we need to figure out the angle. Angle is not difficult since we are given opposite and hypotenuse. So we can find this angle first and then the subtended angle, which will be twice. So sector area will kind of stop here, but we'll figure out what is this angle. So we say sine of angle AOC is 8/10. So that clearly means that the angle AOC is sine inverse of 8/10. There is no need to simplify this. We are using calculators. So, any number is same for calculator. Sine inverse of 8/10. 4/5 will also give you the same result, right? So this angle here is 0.927, we can round it to 3. Now clearly this is half of the subtended angle, so we'll say theta will be twice this number. It is in radians, right? So let's multiply this by 2. And what we get here is 1.8546. Working with radians, go to 4 decimal places for accuracy, right? So that is important for angles. So now we have this angle theta. Let's say this angle theta is known to us. So we'll say sector area is equal to half r square theta. So which is half, radius is 10 and theta is 1.8546. Okay, let's multiply. So it's good to keep the values on calculator. Easier calculations, times 100 for 10 square, divide by 2, and what we get here is 92.73. Okay, we need to now take away the area. So we found this area of the sector, right? So I hope you understand what we got. So we got this area. Correct? It includes the triangle, which we have to take out. So let's find the area of the triangle. So we say triangle AOB area is half of r square sine theta, right? So which is half of 10 square sine of the angle 1.8546. Okay, we'll write down here. So that is sine of 8546, and this value will be multiplied by 100 divided by 2, so I'll do times 50 here. 47.99, so it could be written as 48. Let me write here itself, 48. Right, so that's good. So we got the area. Now it is easy to find the area of interest. So we can say area of shaded region. Correct. So area of shaded region is that from our half circle, which is equation 1, that is half of circle area, which is C, right? Half of circle C. From that, we'll take away the whole sector area. So we'll take the sector area for the given big sector with sector AOB. And then to this, we'll add the triangle area, which is AOB. Is that clear to you, right? So that is how you're going to find the answer. So this first area, we found half of circle is 100.531. We'll take away 92.73 and we'll add the triangle area 48. Clear? To get a result. So let's do this calculation. So we have 100.531, take away 92.73, and to this we'll add 48. And what we get is 55.801. So we'll write 55.8 as our answer. Is that clear to you, right? So we have our answer, which is 55.8 centimeters square, right? Kind of important to write the units at the end, very important rather. But I hope you have understood all the steps. So this involved finding area for sector, finding area for the segment, and then the shaded region, correct? As an added exercise, you can always find perimeter of this, and where you use one arc length S equals to r theta, right? So arc length, let me write, equals to r times theta. So the question for you is find perimeter of shaded region. Okay, so you can always report your answers here. That'd be great. So I hope you understood. Let's move on and take the next question, which is, I think, relatively simple. Question number 2 here is, in the figure below, chord AB has length 16. So this time AB is 16. Okay, so half of AB will be 8. So let me write down 8 here, which makes an angle of 60 degrees at the center. So we're given the angle. Okay, that's great. 60 degrees is given to us. ABCD is a rectangle. OQ is perpendicular bisector of AB. So that is the perpendicular bisector, where OM equals to MQ. So OM is MQ. Find the area of shaded region. So, okay, shaded region, I think we missed it here, but that's the shaded region. Okay, great. So this is your question. Well, I've just cut short the question since a lot of details are there. Q is on the rectangle and all those things. Well, eventually this is what you get. I'd like you to pause the video, answer this question, and then look into my suggestions. Now here is the solution. If this angle is 60 degrees, these two sides are radius, they are equal, that means the triangle is equilateral triangle, right? So we are working with equilateral triangle. AOB. All sides are equal. That means these sides are 16 each, right? Correct. So that is also 16. I thought I'll be finding the angle, so I wrote 8, but it's not required. So we know these two sides, and now we need to find that area. So how will you figure this out? So clearly, here we have one sector which has to be removed from the big triangle. That's it. So we'll find the area of the sector. Sector AOB, which is half r squared theta. In this case, which is half of r is 16, and the angle theta. You have to write this angle in radians, right? So convert degrees to radians. So that is what you have to do. So we'll do 60 degrees is equal to pi by 3, right? So I just wrote direct, okay. So you'll know this, 60 is pi by 3. Conversion factor, 180 degrees, correct? Okay. So strictly speaking, you have 60 here. So we'll do times pi over 180. And when you simplify, you get pi by 3. Okay. So we got this. Now let's calculate the value. So we have pi by 3 radians, right? Everything in radians. We're multiplying that by 16 square and then dividing it by 2. So this gives you a value which is in decimals 134.04. Okay. So we have this here. Now let's figure out the area of the triangle. So what we'll do here is we'll consider half of the triangle first. That will be easy. Right? So that becomes the height. So area of half triangle is base into height times half. Base is O to Q. Now we are also given that O to M is M to Q. We know these two sides are equal, correct? So O to M is the radius, so OQ is 16. So we'll write down here this portion. So OM equals to MQ. OM is radius, which is 16. So MQ is also 16. So O to Q equals to 16. So it's 32. 16 times 2, 32. So this should be 32. 16 times 2. So that is the base from O to Q, and the height is 8, half of 16, right? That's the right angle. That is what you get, right? So area of half the triangle is that much. We'll multiply later by 2. So we'll do at present 16 times 8. So half of 32. So we get 128. Okay. We'll multiply this by 2 to write 256 area of full triangle. Two triangles. So 2 times 128, which is 256. So we got the area of the complete triangle. So clearly, we just calculated the area of complete triangle, which means we have calculated this whole thing. So if I take out the area of the sector, we get the area of shaded region. Is basically area of triangle I shouldn't say now because we have added two sides. So area of quadrilateral which is AOBQ, take away area of sector which is AOB, right? So that's the formula. So area of quadrilateral is 256, from which we'll take away area of sector which is 134, we can write, right? And we get what? 256 minus 134, 122. So that is the answer. 122 units are centimeter square. So 122 centimeter square is the area of shaded region. Perfect. So I hope the steps are absolutely clear. So that is how we could solve this particular question. So let's begin with from where we started. So that was a very important sheet. You have seen how we have even utilized the segment area concept, and in the very first question, which was very complicated, so we had to take out this segment, right? So segment area concept along with all the formulas which we have mentioned here on the paper. So I hope you understand and appreciate that when you are solving questions which involve composite figures having sectors, you should have complete knowledge of all these things. Now, I hope it makes sense. Feel free to write a comment, share your views, and if you want to join our WhatsApp group, you're most welcome. Thanks for participation. All the best.